Okay, we're going to continue looking at areas of shapes. This video is going to be looking at areas of a parallelogram. The first thing we want to do is just compare this to a rectangle and think about what the key differences are between these two shapes. So you may notice, obviously, similarities are they both have four sides, so they're both quadrilaterals. Differences might be, for example, or another similarity is got two pairs of parallel sides. So here you can see these two are parallel. And in terms of the difference between these two is the fact that a rectangle has got all right angles. A parallelogram doesn't. Now, a rectangle is technically just a special case of a parallelogram, because a parallelogram is a shape with just two pairs of parallel sides. Well, a rectangle also has two pairs of parallel sides. It just so happens that the vertices meet at right angles. So it's just something to be aware of. And that's going to help us to have a clear definition of a parallelogram. So a parallelogram is a 2D quadrilateral where opposite sides are parallel, opposite sides have equal length, and opposite angles are equal. So these have been color coded on the diagram for you, so you can see these angles here that angle would be equal to this one, and then the two red angles would also be equal to each other. So knowing that, we're going to continue looking at this and think about how we can work out areas of shapes, of parallelograms. So on this interactive, what you should be able to see is I can change the height or the slant height of the parallelogram. It still keeps opposite sides parallel. I can also change the length of one of the sides. What you will see is in each, no matter which shape I create with this, or which parallelogram I create, if I cut down the vertical height from one of the vertices and then shift it to the other end, you end up with a rectangle where you've got the vertical height and then the base turns out to be that same length as the base of the original parallelogram. So again, this is just another example here of where if I exaggerate the length a bit or the angle and I can drag this along, you will just get a rectangle. So this is showing us that the area of a parallelogram is perpendicular height times the base length. So the formula you need to know for this is area of a parallelogram, same as a rectangle, base times perpendicular height. The thing you need to be careful about here though is when we're talking about perpendicular height, it's this height which is at a right angle from the base. Now you may decide that this is your base if you were to turn this parallelogram around. So I'm just going to show you what that might look like. So the shape in the middle is a copy of this parallelogram. If I rotate it and I change the base so that this is going to be my base, the perpendicular height would be a right angle from there. Now we don't have that measurement on this diagram and it's not labeled, but we could work that out and then that would help us work out the area. So that's the formula that we're going to start using. Now you need to be careful that you do not confuse the perpendicular height with the slant height. The slant height is at an angle and it will be of a longer length than the perpendicular height because of that angle. So you just need to be careful of that. So we do true or false for this. Pause the video and check all the statements and then I'm going to go through them with you. Okay, so the area of the parallelogram is 50. Well, we're going to do base, which is 10, times height, which is 3.6. 3.6 times 10 is not 50, so this is false. It should be 36. Angle ADC is 140. Well, we know that this is 40 here. ADC is this angle here. Now, because these are parallel, we can treat this as a transversal, and then these two essentially are co-interior angles. Now they're going to add up to 180, so 40 plus 140 does equal 180, so this is going to be true. A square with the same area would have a side length of 6. So if you have a square with a side length of 6, then all sides would be 6, and the area of that would be 6 times 6, which is 36, which is the area. So in this case, it's going to be true. 3.6 centimeters is the only perpendicular height. Now this is false, because you might use this as a base, and then at a right angle to that, this is going to be hard to draw, but imagine a line that goes at a right angle to this. It may actually go outside of the shape, but that would be the perpendicular height. We're not going to do that with this example. The other perpendicular height is 7.2. If the base is 5 here, we can work backwards, and we know that 5 times something has to give you 36. So in this case, it's going to be 7.2. We'll look at questions working backwards later. Okay, so pause the video and work out all of these areas, and then I'm going to show you the answers. Okay, 3, 2, 1. Here are the answers for you. Okay, so you can check your answers. A couple of notes about this. These are the perpendicular heights that have been given. They may not have been very accurately labeled there. And sometimes the perpendicular height can be shown outside of the shape, but if you imagine, we can move that line, that perpendicular height, into the shape as well, and it will give us the same thing. This question I is just 2 parallelograms together, so you can work out the base times height in one go, or you can work out 2 separately. Okay, I'll see you in the next video, so where we look at triangles.